Hello friends, today we discuss about kinematics. In kinematics, graphical part analysis today. That is when a particle moves in a constant velocity. What types of graphs and why the graphs looks like that. But when a particle moves in acceleration which has a non-zero initial velocity, then the curve, what type of curve looks like. This type of curve when a particle moving in an increasing acceleration or decreasing acceleration, the curve that is ST curve, VT curve and AT curve, whatever looks like that. And why this is graphs looks like. And all the term we denoted today as subject matter. At first, we discuss about the graphical nature of a line, straight line, circle, parabola, hyperbola, and ellipse. All these types of motion of a body analyzed. But first, straight line. Straight line, case 1, that is case 1. Case 1 means y is equal to constant. Y constant, that is xy graph looks like that. Y perpendicular to y. Y constant, that means constant value of y, that is perpendicular to y or parallel to x. When curve x equals to constant, that is graph that is perpendicular to x or parallel to y when x is equal to constant. And third part, if y equals to mx, where n is the slope of the curve, and then curve is when putting x equals to 0 and we get y equals to 0. When putting x equals to 0, we get y equals to 0. That means initial point is 0, 0. 0, 0. That means the graph y proportional to x. Here n is constant, that's why y proportional to x. These graphs look like that, and y and x. Y equals to mx. If this graph is denoted as fourth graph, that is y equals to mx plus c. That means when we put x equals to 0 value and y get c, that is origin is 0 and c, that is this graph is converted as 0, c, that is positive, that is c point, and this is the graph. Y and x, that is origin. This range is, this point is 0, c point. Now this curve, if this curve is y equals to mx minus c, that is 4, y equals to minus mx minus x. That means when x equals to 0 and we get y equals to also 0. That is starting from initial point, and y proportional to minus x. That is positive value of x, we get negative value of y. That is graph this time. Origin x, y, minus x, minus y. That is here y is negative y, x positive. Here x is negative, y positive. All combination are present. This graph is this type. If this graph is converted as y equals to minus mx plus c, y is equal to minus mx plus c. That is x equals to, when you put x equals to 0, y gives c. So origin is 0, c, and passing through origin is 0, c, and passing through 0 comma c, this is to y and x. This is the curve y equals to minus mx plus c. Number 6. If a curve looks like x by a plus y by b equals to 1, this graph x coordinate cut by the curve is a, 0 and y coordinate cut by the curve 0, b, and that's why the point is a, 0 and this point is 0, b curve look like that, that is x and belongs to y. This is the one type of graph for straight line. Now we analyze as parabolic graph. Parabolic curve, that is y square 4ax y square minus 4ay minus 4ax x square equals to 4ay and y square x square equals to minus 4ay. Fourth graph from parabolic equation, that is in this curve, in the fourth curve, that is y value is square and another variable x is the linear, that is power is 1, and here the one variable x variable is square and other is 1, square another variable is 1, and here square other variable is 1. That means here minus x minus y plus x and plus y are four variables, in where the linear power is 1. The curve of a parabolic is in this direction, that is y, x minus y. The curve looks like this direction. These are the infinite up to infinite curve. This curve is in the direction of positive x for 4ax. If we draw this curve, that is y square equals to minus 4ax, curve is x, that is power is 1, that's why curve is minus x direction. And similarly for this, the linear velocity power 1 velocity is power 1 coordinate is y, that's why this curve is directed towards the positive y. And here minus y, that's why curve directed to the negative y. This is the four parabolic curve. Actually, these curves are necessary for when particle moves in a straight line, when a particle moves in a constant acceleration or constant velocity. This type graph are present, but we draw only for first quadrant graph. Only first quadrant graph or fourth quadrant, any one coordinate from the graph. This is the parabolic equation. Next is rectangular hyperbola. Rectangular hyperbola means xy equals to c square. That is plus x or plus y, that is c square, and also minus x minus y represent as c square. Because c square is a positive quantity, that's why both are positive or both are negative. Any equation choose, that's why the curve are x y x minus y, that is curve looks like that. This is here both are negative, here both are negative, and here both are positive. This graph we study at when PV equals to constant. When we draw graph that is along P and this equation along V. Now to this is y direction and this is x direction. If we put in this equation y x equals to constant, that means this is the rectangular hyperbola that is curve is this type. For Julian's law, HR for Julian's law, HR equals to constant. H is the capillary height and R is the radius of capillary. Then the curve is from y direction x direction, that is H and that is R. This curve also looks like that. So all are the similar curve. Here only PV, HR, this type of curve go on the basic of these equations. Now we study the graphical nature of a particle when it is at constant acceleration or constant velocity or increasing acceleration. First point, when we draw a graph in kinematics, it is basically on ST nature, VT nature or AT nature. Displacement time graph, velocity time or acceleration time graph. Three different part of the graph we draw for different type of conditions. And S is the displacement, and ds by dt is equal to V and dv by dt is equal to A. And also d of dt, in place of V we put the ds by dt. That's why the equation tends to d2s by dt square, that is A equals to. That is S, V and A. That is displacement, velocity and acceleration. When we go from displacement, after that velocity, after that acceleration, then the equation is differentiation. When you go acceleration, velocity or displacement, any other terms from acceleration, then equation will be integrated. Equation should be integrated. Now we study in this equation for different conditions. First, number one condition is for stationary body. Number one condition is stationary body. That is, S is constant. S constant for ST graph. That is, ST graph is constant. S constant means it belongs to y-axis and x-axis. That means we put y equals to constant. In first equation, we discuss the y equals to constant graph represented perpendicular to the axis which is constant. That is y equals to constant. Now, if we want to draw the velocity time graph for this stationary body, S equals to K, that is ds by dt equals to V, that is equals to 0. Constant derivative of a constant is 0. That's why V equals to 0. This graph is look like that. V and T, V equals to 0 curve, that is the V equals to 0 curve. And for acceleration, that is dv by dt equals to 0, A equals to 0. That means curve is T and A, that should be, this is the curve for the particle when particle is stationary, that is ST curve, BT curve and AT curve. Now we discuss the particle. Now we discuss if the particle moving in a constant velocity. Constant velocity, that is v equals to constant, that is k. V is equal to k, constant. Now we draw ST graph, VT graph and AT graph. We draw three types of graph. First, V equals to constant. When we plot, that is y-axis, along y-axis V, x-axis T, then we put y equals to constant k. If y equals to constant, then particle perpendicular to the y-axis. That's why when particle moving with velocity, constant velocity, then VT graph looks like that. If AT graph, V equals to constant, that means dV by dt equals to 0. dV by dt equals to 0. So A equals to 0. A and T curve is, this is the equation for AT curve. Now for ST curve. Actually, when we go from velocity to acceleration, equation must be derivative. Equation must be derivative. Now, if we want to from V to S equation, then it should be integral. That is ds by dt, d equals to ds by dt equals to k, ds equals to kt. That is 0 to s and 0 to t. If we integrate this, ds integration s equals to kt. Now we draw ST graph. That is S and T, ST graph. So along y-axis and along x-axis. Now put y equals to S is along y-axis. That's why we put y in the place of x, and k we put x in the place of t. That is y equals to kx. That means y equals to mx like graph. That means when you put x on 0 and y should be 0. That is of passing through the origin. This is ST graph for a particle which have a constant velocity. Now we study a particle which have a constant acceleration. Constant acceleration. That means A equals to constant. Draw the AT graph first. This is along y-axis, x-axis, this is origin. Now y equals to constant, A belongs to y, that's why we put y equals to constant. That is perpendicular to y. If acceleration is constant, then A is equal to, looks like that, the perpendicular of y. Now dV by dt equals to k, that is A equals to dV by dt, that is equals to k. Now for VT graph, the equation dt 0 to v and 0 to t. 0 to v, that is v, and 0 to t, kt. The VT equation is dt. It is placed along y-axis, x-axis. Now put y equals to kx. This is similar to y equals to mx. That's why graph is this type. For a particle which have a constant acceleration, this graph is that. Now for ST curve. ST graph, that is V equals to kt, ds by dt equals to kb, ds equals to kt dt. Now integrate 0 to t, 0 to s equals to k t square by 2, because formula is x to the power n dx, that means x to the power n plus 1 by n plus 1. That's why t dt integration t square by 2. That is t square summa, t square equals to 2 by k s. This is t, this is s along y axis and t along x axis. Now we put place of s y and place of t x, that is x square equals to a constant, that is we take 4a similar to 2 by k and a y, that is x square equals to 4ay. The curve is a parabolic curve. We draw the previous section, that is 4ay curve. Now the linear part, that is 1, power of 1 is for y, it is positive direction, that's why the graph looks like that. Graph is this type. It is for ST graph for a constant acceleration particle. If now we change a condition, that is here when the velocity time is t equals to 0, the velocity is 0. That is no initial velocity for constant acceleration. Now we define the case, similar case for when constant acceleration but a non-zero initial velocity. But non-zero initial velocity, non-zero u, that is non-zero initial velocity. That means when t equals to 0, time 0, then has a velocity u. The equation is v minus u equals to kt, that is v equals to u plus kt. So equation, we draw y x curve, that is along v and along this x direction is t. Now putting in place of v is y equals to, this is constant, that is c plus k and t x. This graph is y equals to mx plus c. Similar curve, we first study this curve, and similar to that, this is the equation of curve for a particle constant acceleration and has non-zero initial velocity. That means it has an initial velocity, that is the graph for the particle. Now the displacement should be changed, equation of displacement should be changed. This is from here, ds by dt equals to u plus kt, that is ds equals to u dt plus kt dt. Now s0 to s, when time t equals 0 to t and 0 to t, this is the equation. For integration ds, that means s, that is upper limit, the lower limit and upper limit s equals to ut plus k t dt. Its integration is t square by 2. This equation s minus s0, this is minus s0 equals to ut plus half k t square, s equals to s0 plus ut plus half k t square. This equation also a parabolic equation with a constant. That means when we put t equals to 0, then the value of s is equal to s0. That means t equals to 0, we put s0. This graph is this graph. We put in y equals to s0, that means c plus ut মানে ux plus half kt square, half k x square. This is a parabolic equation and linear part of this part is y. That's why graph is y direction. But here when you put x equals to 0, then we get y equals to c. That is c. 0 comma c point. The graph is parabolic curve. That's why it is starting from this. And this value is from this value s0. S0 is the value. For ST curve, for this equation, constant acceleration with non-zero initial velocity. Now we study particle with constant retardation. A particle with constant retardation. Constant retardation means minus a equals to constant. Minus a equals to constant. That is a equals to similarly constant. The curve is for AT along this direction A and along this direction is T. The curve is AT, that is perpendicular to y-axis, similar to the previous equations. AT. Now we derive for velocity time graph. Now we derive the equation for velocity time graph. That means minus dv by dt equals to k. dv equals to minus k dt. That means if we integrate, v equals to minus k. Now we plot along y-axis and y-axis v and x-axis t. Then we put in place of velocity the value of y. That means y equals to minus kt. That is minus k. In place of t is x. That's why x. Y equals to minus mx curve. That means curve is, that is the curve y equals to mx. When a particle it has non-zero initial velocity, a particle that is t equals to 0 and v equals to 0 to v, that is initial velocity is 0, at that time the equation is this is. If we study the constant retardation motion of a particle with non-zero initial velocity, that means at t equals to 0, particle velocity is u, that is similar, that is u. The equation changes from this part to, that means v minus u equals to minus k. V equals to u minus k. Now that is velocity and time x direction. Time is x direction and velocity along y direction. Now put in place of velocity y, that is y equals to, there is initial velocity, that is constant, c minus k equals to x. Y equals to c minus mx. This is the curve, and this graph we first discuss about this curve, and this curve looks like that. This is, and here this velocity is u, initial velocity, and this is the curve for retardation, constant retardation, and also has a initial velocity. Initial velocity and final velocity, not zero, the final velocity. That is the curve. Now we study about the ST curve. When we draw ST curve, this is v equals to minus k, ds by dt equals to minus k, ds equals to minus kt dt. That is 0 to t, 0 to s equals to minus half k t square. That is curve is s and t. This curve is looks like that. It is also a parabolic curve, negative. That's why this curve is look like that for the first quadrant, below the fourth quadrant. This is the ST curve, and this is VT curve, and this is AT curve. It is for constant iteration. If we want to draw the increasing acceleration, if we want to draw the increasing acceleration curve, increasing acceleration curve. Increasing acceleration means A proportional to t. Increasing with increase of time, the acceleration should be increases. That's why A proportional to t. That is A equals to kT. That is increasing graph. For A equals to kT, AT graph looks like that. AT curve looks like that. This is y direction. This is x direction. Now we put in place of A y. Y equals to ax. That is y equals to similar to x mx. That means curve is this type. For increasing acceleration, AT curve is looks like that. Now A equals to dv by dt equals to kt. dv equals to kt dt. That is v equals to half k t square. From the previous integration, that is v equals to half k t square. Now if plot y equals to, that is y and that is x, we plot t and this one you plot velocity. Now in place of velocity you put in y equals to half k x square. That means x square equals to 4a y. This is the y linear part. The curve is in the y direction. Positive y direction. This for AT curve, VT curve for a increasing acceleration particle. If this graph looks like that for a decreasing part, it is increasing rather than increasing, it is decreasing acceleration. Decreasing acceleration. For decreasing acceleration, A proportional to minus t, that is A equals to minus k. A is minus k, that means graph is this type. If particle has initial velocity, then graph looks like that. A equals to minus k. And for here, dv by dt equals to minus k, that is minus. That is minus. That is minus. The curve is like that. For VT curve and for AT curve. This is all the graphical part of a kinematical equation for derived by the equation. If we study about the equation, then we draw the easily any curve from the given condition. That's why. Thank you for watching.